it's time to dive deeper into our application components and see how everything is implemented. Let's begin by first focusing on the Firebase components. We will be using two Firebase components, one for hosting our front-end application and then another as a serverless database. The first thing we need to do before using these components is creating a Firebase project. The Firebase project can be created at firebase.google.com, and it starts by creating a project name. Once you create a project name, a project ID is automatically created, but it might also be beneficial to create your own project ID. This project ID is later referenced in all other components such as Cloud Run, creating container repository, etc. The next few steps are pretty self-explanatory. Now remember, this is a Firebase project. When a Firebase project is created, Google Cloud Project is also created automatically. However, the consoles for managing the Google Cloud Project and the Firebase project are different. Once the Firebase project is created, let's dive into creating a Firestore instance. Cloud Firestore instance can be created in pretty much the same manner as everything can be done through the console, and the wizard questions are pretty self-explanatory. Once the Firestore instance is created, you can manage the Firestore instance through the Firebase console itself. You can set up additional security for Firestore through rules, create indexes once your collections are created, and you can track and monitor your usage of the Firestore application. At this point, we will now move on to creating a hosting environment for our front-end application. For creating the hosting environment for our front-end application, we need to follow a certain number of steps, which involve working and operating through command line utilities. Firebase hosting is managed through a command line utility called Firebase Tools. And the first thing, therefore, is to install the Firebase Tools using npm. Moving on from the Firebase components, where we created our serverless database and then pushed our front-end app to a serverless hosting service, let's move on and take a look at the middleware components. Our middleware consists of three microservices, one for order, product, and invoice. Each of these microservices is containerized and stored as an image in Cloud Container Repository. This image from the container repository is then deployed in Cloud Run. Let's now take a look at this. Our Visual Studio Code shows all the middleware components, the invoice, order, and products. We will be first working on our product microservice. Our product microservice is written in Node.js and contains all the endpoints that are required for displaying all the products or looking up a product by its product ID. This is an Express Node.js app. We also take care of the response header so that this API can be called from any client. We then set up the Firebase admin so that we can instantiate a connection to the Firestore database and then operate on that Firestore database in order to retrieve all the product records. Please refer to the Firestore Node.js client library documentation. Our application then also consists of a package.json, and package.json lists all the dependencies that we will be using in our product microservice. A Docker file is then created that would then define the shape of our container image. Once the application is ready, we now have to deploy it. So we do that by the gcloud utility on your laptop to package our application and upload it as a container repository image. So while the container is being packaged, let's go ahead and look at the Google Cloud Platform console. We will first take a look at the available images in the container repository. Because this is the first time we are ever gonna create our container image, the repository shows there is no container image at this point that's available. At this point, once we get a success, let's go ahead and refresh the container repository page. We find that our product container image is available in the repository. We also have a tag. This is automatically created by gcloud, and this is the path of our container repository. Once our container repository is created, our next step is to go ahead and create a Cloud Run service. At this point, we do not find any Cloud Run service. Let's go ahead back to the console and run the command to deploy our image, which we just created as a Cloud Run service. This Cloud Run service can be deployed either on a Kubernetes or any other container orchestration service. But at this point, we're going to say that this is going to be a Cloud Run managed service. So we are not going to worry about the scalability and creating a service, etc. aspects of our application. So this will be a purely serverless component. So at this point, we can see that our Cloud Run service is now created for products and is available at this address. We can run a quick curl command to see whether this service is available. Let's go back into the Cloud Console and we should now see that our product service is available in Cloud Run. This service at this point has only one revision because this is the first time we have created a Cloud Run service. And as we deploy any additional changes, a new revision is automatically created by Cloud Run. We can also check the logs. Because we have two more services, the process is going to be exactly the same. Let's quickly walk through some of the key files from the other services. Looking at the order microservice, we again have the application here that basically has endpoints according to our application. We also then create a Docker file, which would then be used to build a Docker container. We went ahead and created all the three containers and deployed all the three Cloud Run services. Let's quickly take a look at all these Cloud Run services. So at this point, going back in our architecture, we can see that we have deployed our front end on Firebase hosting. We have our database that is running in Firebase Firestore, and then our microservices for orders, products, and invoices containerized. And these container repositories images are then deployed in Cloud Run services. Let's now look at the last component of our application, which is the event-based framework provided by Cloud PubSub. In the Google Cloud Platform console, you can go to the PubSub service, which lists all the topics that have been created. Let's go ahead and create a topic. Our topic is going to be called Order Created. Now, once a topic is created, we need to create a subscription so that as messages are published to this topic, they can be listened to. So if we scroll down on the page, we can go ahead and create a subscription. The name of our subscription is going to be Generate Invoice. And this is just the name of our subscription. The real decision is about here is how do we want this subscription to work for us? In our case, we want that the subscription is going to push our messages to an endpoint. And the endpoint in this case is going to be the endpoint of our Cloud Run application for creating the invoice. If we look at the invoice, the endpoint of our invoice service is about here. Let's take it back to PubSub, and we are going to say that this is going to call this endpoint as soon as a message is published to this topic. This is going to be a post call, and all the message data that is received by this topic is sent as a request body. There are a few other controls, but I would leave that up to you for you to read the documentation for Google Cloud PubSub. So going back to our architecture, we have created a topic order created, which will then be called upon by the Cloud Run, and a message will be posted onto that topic. The subscription that we created was a push type. That means as soon as a message is received on that topic, the REST endpoint that we just provided is going to be invoked. And that happens to be the endpoint for our invoice to be generated. Let's look at the code to see how these pieces are tied together. So first, let's see our orders microservice. In our orders microservice, we have first of all made sure we have installed the dependency for Google Cloud PubSub. In our index, we have then instantiated a PubSub client so that we can operate on this PubSub topic. The name of our topic is orders created. So the way this is going to work for us is when a new order is created, we are going to insert it in our database, which is Firestore. But at the same point, we are then going to publish an event and send that data as a message. This is event-based architecture where instead of performing a whole lot of business logic and capturing for all the successes and failures, we are going to let two microservices work independently based on an event. So once this event is generated, let's see in our invoice microservice, how do we handle that? So our invoice microservice was going to call the post service at the root. And what we're going to see here is we are going to receive the message data. And the purpose of this microservice is basically to generate a PDF invoice and store it in the Google Cloud Storage. Once the invoice PDF is generated, we update the order in our Firestore database with the reference to the file that is available in the cloud storage. And for this, we have leveraged a ready-made service available from Invoiced. So refer to this documentation to read more about how the service works. But on a high level, once we generate the service, we create a file in the cloud storage. And once the file is created, we basically then update that particular order ID with additional information, as in the URL of where that invoice PDF can be found.